Hello and welcome to helpyourmath.com. In this video, we're going to look at examples of rationalizing the denominator. We're going to look at denominators with indices of 2 or bigger, and we're going to have single terms in the denominator. Now, what's important is when we rationalize the denominator, we're trying to figure out what we need to multiply it by that would obviously make the denominator rational. And so what we want to be really careful is keeping in mind the perfect powers of the index. So let's look at some examples. First, we have 4 root 3 divided by the square root of 50x. And what I noticed is that 50 is kind of a big number, and it has a perfect square factor in it. The more work I do up front, the less work I'm going to have to do later. So I'm going to go ahead and simplify the square root of 50. The square root of 50 is the square root of 25 times the square root of 2, and I'm just going to attach the x there. And then the square root of 25 is 5. So this becomes 4 root 3 over 5 root 2x. Now I just need to get the root 2x to be rational because 5 is already a rational number. So I would need to multiply, in order for 2 to be multiplied to something that's going to be a perfect square, I would need another factor of 2. And same with x. If I need x to become something that I can take the square root of, I need another factor of x. Then whatever I do to the denominator, I do to the numerator, and we simplify. In the numerator, we have 4 radical 3 times 2 is 6 times x. In the denominator, the root 2x times the root 2x becomes just 2x. It pops out of the radical. And then we would have 5 times 2x, giving us 10x. Now you might think we're done, but we're not, because we have a coefficient of 4, or a factor of 4 in the numerator, and a factor of 10 in the denominator, both of which are divisible by 2. So this would become 2 times the square root of 6x divided by 5x. And you might be thinking, wait, but 6 is also even. Why didn't we divide it by 2? Well, 6, that's not 6. That's the square root of 6. That's the same reason why we can't simplify this top x with this bottom x. This x is not x, it's the square root of x, whereas this one is x. So we can't simplify. So this would be our final simplified rationalized denominator answer. In our next example, we have 9 over the square root of 3a. This one's a little bit nicer. The square root of 3a, we need another factor of 3, and we need another factor of a. So we're going to multiply both the numerator and denominator by the square root of 3a. And that will give us 9 times the square root of 3a over square root of 3a times the square root of 3a is 3a. And we're always going to make the assumption in these videos, I should probably write it up front, that the variables are positive numbers. So it can't be 0 because we have a 0 variable in the denominator, and it can't be negative because of the radical. So we're going to assume that all variables are positive. We're not done yet because we have a regular factor of 9 and a regular factor of 3. So this is going to simplify to 3 radical 3a divided by a, and that's as much as we can simplify. Our next example is a little different because here the index is 3, not 2. So we need to be really careful about our perfect cubes. And if we think about 9, 9 is 3 squared. So we're only one factor of 3 away from a perfect cube. So here I need to multiply by one more 3 because that will give me 3 cubed, or 27, which is a perfect cube. Here I only have one factor of x. So to make it something that's a perfect cube, I would need to multiply by 2 more x's, giving me x cubed, which is a perfect cube. I'm going to do the same thing in the numerator, multiply by 3x, the cubed root of 3x squared. And this will give me 7 times the cubed root of 3x squared divided by, and then down here, let's be really careful here. So 9 was 3 squared. We multiplied another factor of 3. So we end up with 3 cubed under that radicand and x cubed. And both of those exponents will cancel with the index, leaving us with 3x. We can't simplify 7 and 3, so that would be our final simplified rationalized denominator answer. Our last example, we're looking for the 4th root. So first of all, the 4th root of 1 in the numerator is just 1. So that will be 1 over, I'm not going to write that there because I'm going to run out of space. I'm going to put it over here, 1 over the 4th root of 27x. Now we want to think about 27 and we want to break it down into its primes. 27, as we might recall from the previous example, is 3 cubed. Now, I'm looking for perfect powers of 4. I have 3 factors of 3 so far. I just need one more factor of 3 for it to be a perfect cube. And if you look at the numbers, 27 times 3 is 81. 81 is a perfect power of 4. And then x we need 3 more factors of x to make it a perfect power of 4. So we're going to multiply by x cubed. We're going to do the same thing in the numerator, multiply by the 4th root of 3x cubed. So again, what happens in the denominator, we have this 4th root. Here I have 3 cubed, and here I have one more factor of 3. That's going to give me 3 to the 4th. Here I have x to the 1st. I multiplied it by 3 more factors of x. That will be x to the 4th. And then what we'll see is that the power of 4 will cancel with the index of 4 will cancel with the powers of 4, leaving us with a numerator that's very irrational of 3x cubed, the 4th root of that, over these will cancel, leaving us with 3x, a nice rational denominator.